Thailand's durian export market generates hundreds of billions of baht annually. It operates as a massive, highly lucrative agricultural engine. But maintaining that top position is becoming difficult. Regional neighbors are rapidly expanding their own cultivation footprints, directly challenging Thai market share. At the same time, exporters face severe logistical friction. Strict international food safety standards and the extreme perishability of fresh fruit steadily erode profit margins along the transit route. Relying solely on historical geographical advantage and raw production volume is no longer sufficient to maintain market leadership. To survive the squeeze of rising competition and tightening margins, the Thai durian industry has to restructure, transitioning from simple commodity extraction to engineered value addition. The proposed solution to this commodity trap at the national level is the Bio-Circular Green, or BCG, economy model, which mandates sustainable, value-driven agricultural practices. To test whether this framework yields competitive advantage in reality, we look to an empirical study by Jirawadi and Takarn, published in 2026. This study features a robust methodology, gathering data from 400 key supply chain stakeholders across major cultivation areas, including farmers, collectors, and exporters. This diagram shows the study's conceptual framework. It proposes a specific causal pathway for how value is actually created in the durian market. The model is built on 4 core nodes: operational performance, supply chain collaboration, value added, and overall competitiveness. Having a theoretical math is a good starting point, but we need to see the math. We will use the study's multiple regression data to determine if these causal pathways hold up under statistical scrutiny. Let's focus strictly on the left side of the framework, the 2 independent variables acting as the inputs for the supply chain. First, operational performance measures internal capabilities. This includes controlling product quality, minimizing production costs, speeding up delivery time, and maintaining operational flexibility. Second, supply chain collaboration measures external network strength. This evaluates cross-organization information sharing, joint planning, and the level of trust between different stakeholders. Managers traditionally view these 2 inputs as distinct silos. One deals strictly with the factory floor and internal processes, while the other manages external partners and logistics. However, in this model, both inputs theoretically feed into a central mediating variable, value added, which includes physical improvements like advanced processing, specialized packaging, and branding. To validate the resource-based view of strategy, we have to quantify exactly how much weight each of these isolated inputs carries in driving real-world value. This table displays the first multiple regression analysis, testing our 2 inputs against value added. The adjusted R-squared value sits at 0.840, indicating that this is a robust and statistically significant model. These inputs explain 84% of the variance in value creation. Looking at the individual coefficients, the beta for operational performance is 0.644. This high beta value confirms that internal operational rigor is the primary driver in the creation of value added. Further down, the beta coefficient for supply chain collaboration is 0.339. This reveals a secondary relationship. Network collaboration is a vital supporting factor, but it does not lead the value creation process. When we map these statistical findings back onto our visual framework, the causal weights become clear. Value addition in agriculture is primarily an internal operational engineering challenge, which is then subsidized by a collaborative external network. Engineering high-value products is one thing. The next critical question is whether that engineered value actually dictates market dominance on a global scale. To answer that, we shift focus to the final, rightmost node of the framework, the dependent variable of competitiveness. In this study, competitiveness is defined by metrics like market share capture, product differentiation, market responsiveness, and overall export potential. The second regression table tests exactly what structural forces drive this external market dominance. The beta coefficient for value added sits firmly at 0.536. This confirms the core hypothesis. Engineered value acts as the primary catalyst for dominating the export market. But the data in this table reveals a critical anomaly. The beta coefficient for supply chain collaboration directly impacting competitiveness is 0.400. This represents a structural bypass. Collaboration exerts a direct, independent influence on market competitiveness, operating separately from the value-added path. We can update the visual model to reflect this unexpected dual-force mechanism. Supply chain collaboration has a unique dual utility. It serves as an internal ingredient for product quality and functions as a standalone external competitive moat. We now have a fully weighted, empirically validated model mapping the path from farm operations to global market share. The primary pathway from operational performance to value added directly supports the classic resource-based view of corporate strategy. The regression data proves that internal operational capabilities form the bedrock of strategic advantage. Meanwhile, the secondary bypass from supply chain collaboration to competitiveness aligns with modern green supply chain management principles, proving that network integration is a distinct, measurable asset. This dataset proves that these strategic frameworks dictate real-world outcomes in high-stakes agricultural practice. This brings us back to the macroeconomic stakes and the transition to the biocircular green economy. The data shows that the Thai durian industry cannot survive long-term as a mere extraction and transport network. The first actionable policy mandate is clear. Executives must aggressively elevate internal operational standards through advanced processing, quality control, and superior packaging. The second mandate requires stakeholders to invest heavily in building robust digital collaboration platforms, locking in their network strength against regional rivals. Sustained global competitiveness is not simply grown in the ground. It is structurally engineered through ruthless operational efficiency and seamless network collaboration.